people are here. Okay, all right. So welcome everyone. So to another session of virtual quant marketing seminar. Today we're very excited to have our old friend to the series, Dean Eckles from MIT, who's going to talk about algorithmic pricing and consumer sensitivity to price variability. So as always, please feel free to ask questions. If you're in the audience, please type your questions and we'll try to redirect it to the speaker. So floor is yours, Dean.
Cool. Yeah, it's really a pleasure to take this role to be on the other side of the process here in VQMS. And so, was thinking a lot about what to present, and this work with Diego Aparicio and Madhav Kumar just seemed like the best fit for this audience. So we hope you think it's interesting. And there's some aspects of this that are kind of work in progress. And so really keen to get feedback about some of the different directions to take this. So kind of the jumping off point for us with this was really seeing just how much price variation there was in some data we had from an online retailer that I'll tell you more about as we go along. But here's what the price time series looks like for one particular product. We all some fruity snacks, the variety pack. And this is the price that you just see over this, brief period in April. This is 15-minute level price data for a 2-week period, right? And so there's a bunch of rapid price changes happening during this time period for this product. Now, some of the price changes are kind of tiny, right? At some points, you can just barely see that the line's going up and down because, just some cents are changing. But other of these price changes are much more substantial, right? This is a feature of, at least some version of what we would generally call algorithmic pricing, where there's an algorithm setting prices, and this is often going to result in a lot of rapid and sometimes substantial price changes. So what we're going to ask in this work is how this algorithmic pricing affects consumer behavior. Now, that's kind of like a big question, so we're not going to answer all the ways that algorithmic pricing could affect consumer behavior, but we're going to focus on a particular aspect of that, which has to do with sensitivity to price. So algorithmic pricing has been prevalent for a while in particular categories, right? So we've all been familiar with the idea that depending on when you buy your airline ticket, the price might be different, and a lot of that is set algorithmically. Certainly, depending on when you open your Uber ride-sharing app, you're going to be getting different prices, right? So algorithmic pricing, we think of it as automated pricing that's trained using some rich set of high-frequency inputs so that the prices might be changing frequently, and they might be changing for different classes of customers, like different by geography. Though algorithmic pricing might not be the same as actually simultaneously showing different prices to different customers who are in the same geographic market. You could still have really rich algorithmic pricing happening even if two people who are in the same jurisdiction are going to get the same prices. So algorithmic pricing involves lowering the cost of changing prices. It becomes really easy to, once you have algorithmic pricing in place, to just keep changing prices. And it automates that. So we've got low menu costs, and we're just going to see a lot of price changes. Now, I think one way that people usually think about algorithmic pricing is that it produces a bunch of between customer variation, right? So some customers, depending on what time of the day they're looking for something, they're going to see different prices than, that was kind of weird. My screen sharing stopped, I guess. They're going to see different prices than other consumers because they maybe have some different characteristics by being in a different place at a different time. That reveals something about their willingness to pay, and that's going to result in them getting different prices, right? But I think what's interesting to us as well is that this involves.
So sorry to
yeah,
I'm still not seeing your screen.
Yeah. I'm working on that. So I think one interesting thing, though, as well, is that it does also involve within customer variation, where the same consumer might see multiple prices for the same product, right, over time. If they end up seeing, visiting a particular product page multiple times, they might be seeing that product at different prices, right? And so we think that that's kind of an interesting aspect of, algorithmic pricing that can then have effects on consumer behavior. So certainly algorithmic pricing seems like it's increasing in its adoption. Right? It's showing up in all these cases like retail where prices are just changing really frequently. A lot of sellers on Amazon Marketplace have automated their pricing. And then even in brick and mortar settings, there's technologies that maybe make it easier to change prices more frequently as well. Okay.
Can I
certainly
ask a quick curiosity question? Is there any within trip variation in prices? So when I get the product on the shelf, the price is one. When I'm at the checkout, the price has changed. How do people handle that in practice?
Yeah, I don't know how you would handle that in the retail setting. And I think some of that is they're still changing prices on a much slower pace than what we're showing here, which is online. In online, you can still do that in kind of an add to cart. Once it's in your cart, then the price is going to be fixed. But in the physical store, my guess is that they're just doing a lot slower changes. And I know in some categories, I think maybe we've seen this in VQMS at some point, that it's, a lot of the detailed prices might be different prices for different expiration dates of different products and stuff like that. So there's some ability to track what exactly is going on there. So certainly there's been a lot of other work on algorithmic pricing, including, how should you do algorithmic pricing? We're not going to really tell you that exactly. We're not going to be doing a bunch of algorithmic pricing work ourselves. And there's been a lot of interest in the competitive aspects of this. What happens when there are multiple firms engaged in algorithmic pricing? Are they going to end up colluding with each other, or is this really beneficial to consumers? You might think this is a quick way to end up in some kind of Bertrand competition. What we're going to be looking at is how exposure to numerous prices for the same product affects consumer behavior. So what happens to consumer price sensitivity in particular, right? If I'm seeing lots of different prices for the same product, how is that going to change how responsive I am to price in choosing between products or deciding whether to buy a product at all? Okay. And I think we can all think of reasons that this might go either way, right? Like how exposure to lots of prices affect my price sensitivity. One story that we're going to kind of emphasize is one around salience, right? That this can just make price something that I think a lot more about, I'm more aware of. If I'm sort of noticing that this is changing, it becomes something that I'm just thinking about more, right? So that would suggest an increase to price sensitivity. You could also imagine that, and there's some evidence around this from a longer literature in marketing, that maybe this could induce some kind of reactance from customers feeling like this is unfair or there's something undesirable about this. And so this is sort of some of their psychological reactance against the firm. But you could also think that it could perhaps decrease price sensitivity through some story about changing reference prices in some way, that maybe the reference prices become less established in various ways, right? Which would be a key input to how people would make those sorts of decisions. So just to kind of preview our results, we're generally going to find an increase in price sensitivity. And we do have some evidence around the idea that this is driven by salience. Okay. But to jump into what we're going to do, we have a few different approaches based on first some weekly data, but I'm really going to focus here today on consumer level exposure to many different prices through a few different approaches. And then if we have time, we can talk about our lab experiments as well. But all of these suggest an increase in price sensitivity. So the empirical data we're going to work with are 14 months of clickstream data from a large online retailer in the United States. And we're going to observe the prices even when people aren't purchasing, which is important, right? So we can just see the prices changing over time. There's actually 2,000 products, a bunch of different departments, and a bunch of finer grain categories as well. we see around 600,000 users over this time period, making millions of visits and millions of purchases. So during this time period, there's actually a substantial increase in the retailers' use of what we would think of as sort of really typical algorithmic pricing. I'm not saying that they're using algorithms to price before and then suddenly they turn on, but rather that signs of sort of some of the things that are really characteristic of algorithmic pricing, which is frequent price changes, become more widespread. And so here across a whole bunch of different products over time are the weeks in which those products have above median absolute price changes and also at least 3 price changes. So it seems like overall that there's a shift towards more price changes. Okay.
Hi, Dean.
Yeah.
This is Tom here. I have a quick question about this. So is this price changes anything different from dynamic coupon distribution? In the sense that do consumers see the price changes only to themselves, or they perceive the price changes as some highly frequently price changes that appear to everyone?
The retailer is not showing different prices to different people at the same time for the same product, but is just changing the price really quickly. So I can't speak to the exact consumer perception of these changes, but these are not price changes that are experienced as, hey, here's a coupon for this product, but that actually, as I'm just browsing the search results in a product category or viewing a product page, the price is just different than what it was before. Yeah.
Dean, another question.
Mm-hmm.
Do consumers buy one product each time they go to the store, or is it typically multiple products?
Sometimes they buy multiple products, and sometimes they don't buy anything at all on a given session when they visit. And we also observe those sessions. Yeah.
One more quick clarification question.
Yeah.
So since you mentioned that this is clickstream data, do you observe also the products that people didn't click on and their prices? Or
Yes.
is this based on a click?
Mm-hmm. Yeah. Yeah. We know what the other products were in some category. And then in the search results, we actually know what the products are that appear in the search results. And so actually, that's one of the things I really like about this, that this was a bunch of work to do that Madhav and Diego really did all the heavy lifting with this, but is that we observe the timestamps for user visits, product views, purchases, and prices. And we actually can see if a user is looking at a search results page or in some category, we see all the listings there and all of the prices. And so we're going to count a user as being exposed to a price for a given product if they see either the product detail page, which they might have gotten at from some search or somewhere else, right? Or if they see it in a search results page as well. And then you'll see we'll actually make some use of the fact that we have all these prices for the other products that they're not seeing as well as part of one of our identification strategies. So this is kind of what you can imagine happening, is that there's this consumer who visits 4 times and sees the same product 4 times. Okay. And here, when they visit on January 14th, they see it at $4.99, then they later see it at $3.99, and then the next 2 visits, they also see it at $4.99. So they have seen 2 unique prices for this. And so we think of that as one of the measures you could have of some price variability stock that they build up, okay? And we can imagine computing that price variability stock for one particular product at a time or for all the products that they're seeing. And we're gonna mainly focus on the latter. So, not just on the product I'm considering buying now, but in all the products I've been looking on this website, am I seeing multiple prices for each of those products over time? So this is then this variable that we're going to be interested in. So it's not that we're going to mainly look at the effect of the firm adopting algorithmic pricing. We're thinking about this much more in terms of consumer level exposure to changing prices, which of course is is caused by algorithmic pricing, but it's one of the many things that algorithmic pricing does. Okay, but we're going to kind of zoom in on that exposure to changing prices. And indeed, people are exposed to varying degrees of changing prices. So just thinking about a consumer's visits to a single product, say somebody visits a product twice. Well, they could either have one price that they see or two prices that they see. Maybe if they visit it 5 times, they might see 1, 2, 3, 4, or 5 prices, right? So we do actually have this kind of conditional variation that, of course, if you visit more often, you're going to see more prices, right? But if you, even conditional on the number of visits, there's a bunch of variation in how many prices you see.
Dean, just a very quick question. Do you know how the algorithm works, or if it takes into account the history, or I don't know what types of consumers are on the platform right now, or
yeah, I can't say that we don't have the algorithm ourselves, unfortunately. I think it takes into account a number of things, some of which can even be sort of more supply side things about, are they running out of a particular product? But yeah, it could respond to, who's using the service at a particular time of day. And it does vary based on the US state that they're in. So the prices are the same for people at the same time within a state, but across state lines, the prices are changing, presumably both for demand and supply reasons. Yeah.
Dean, sorry, just one more clarification. I guess back into your last slide, just so that I'm thinking this correctly. What's the type of data generating process I should think of for the user, of why the user keeps coming back and seeing this website on July 14th, 16th, 18th, and 20th? So what's the underlying process that sort of generates this, that generates some of this sort of information?
Yeah, I think that's a great question, because we do try to think a little bit about this, some of the details of this. So one aspect of it is presumably if they're visiting the 4th time, they are not completely satiated with respect to this product. So either that means that they didn't buy the product on the previous visits, or they bought it and they still want more, right? I think would be one of the common scenarios that would generate this, right? If this is this is a product that I haven't used up yet, then I'm not necessarily going to be shopping for it yet. But a lot of the products in these categories are really consumables, right? So whether they're food products or, household paper goods or these sorts of things, there are reasons why I might shop for the same item again. But also in some cases, I might just view a product as part of a shopping trip that doesn't result in buying that product, or that does result in buying that product. Yeah. Is that, yeah.
Oh, sorry. Oh, so there are 2 questions from the audience that are kind of related to. So one is related, I think, to Aniko's question: are the price variations potentially targeted in any way to observe user characteristics?
Mm-hmm.
And then the other question is, what are you? So how are you potentially thinking about how consumers memorize all the exposed prices when they visit?
Mm-hmm. Right. So yeah, on the targeting to consumer characteristics, the prices are targeted at the state level. And then you could imagine that, typically over time, the retailer could learn that consumers that visit at a particular time of day are more or less price sensitive. And so you might, change prices in that way. But we're going to generally be thinking that the price at least is not responsive to the particular consumer visiting, which could just be a consequence of the idea that there's sort of some infinitesimal part of the overall visitation by consumers at that time. So it could be that the price is changing because customers like you are visiting right now, but we're not going to be worrying about, and I hope people find that okay, that we're not going to worry about the idea that the price is what it is because you are visiting right now, and that it's actually causally downstream of your visit, which I think from what we know about the algorithm, that just was not possible. Yeah. Now, as far as, this number, this price variability stuff, do consumers really remember all the prices they're exposed to? And I think we don't want to assume that they remember all the prices that they're exposed to, but we're going to, imagine that they somehow remember something about the idea that there are price changes. Now, what the right way of representing that causally efficacious version of the effect of that exposure is, I'm not sure what the right way of representing that is. We're going to mainly work with this price variability stock of this kind and generally be working with it on a log scale. So we're thinking about kind of effects of multiplicative changes in this price variability stock, but there's other ways we could represent that. And maybe there's some that could be better informed by work, say, from cognitive psychology about how people represent some of these things that are changing over time. Cool. So I think I'll go ahead and jump into thinking about how we'd see how this price variability stock influences consumer behavior. And so we're going to do a lot of this through models generally of this kind, where we're going to be modeling the number of units of some product that a customer I purchases at time t, okay? And then we're going to be looking at how that varies based on the price of that product at that time. This price variability stock, which that's something that's built up at the customer time level. So customers have this price variability stock that spans across multiple products. So even though I'm visiting a product for the first time, I may still have a price variability stock from seeing all the prices changing on other products on this website. And so that's capturing our exposure to this price variation. And then we're going to also consider an interaction term between these so that the price sensitivity could be affected itself by my exposure to these changing prices. We have some time varying covariates, and then some fixed effects for the user, for the product, and for the week. And we're going to generally do this through this kind of a modeling setup where we're using this log link model in order to consider this multiplicative model for the outcome that we have a lot of zeros in the purchases. So we don't want to just log the outcome, which is a count of purchases, but instead use this kind of quasi-Poisson model. And all the results I'm going to show you use cluster robust standard errors that are using users and products as clusters. So that's kind of the basic setup. Now, right from here, we can just do things with the observational data that we have given this fixed effects setup. So we're going to have some more sophisticated identification strategies, but just to give you kind of a taste of what these kind of results could look like, could look something like this. So we consider that an increase in price sensitivity due to this price variability stock. Well, this is where I realized that there was like a subtle color of gray that I hadn't seen before. So we're predicting the number of units that somebody purchases. This is affected by the prices they see, this price variability stock, and the interaction of the price variability stock and the prices. And so as we expect, higher prices cause people to buy less, right? So that's good. I think this is on the scale with a lot of similar results in this area. And then this price variability stock is associated with higher rates of purchases. Maybe that's not surprising. Hopefully, algorithmic pricing is causing people to purchase more. But then the interaction is negative, such that if you have higher levels of this price variability stock, you're more sensitive to prices. Okay, so that's kind of the basic result. I wouldn't say that this is our preferred specification, because this is just popping out of an observational fixed effects model here. So we're going to try to think more about how to, how to do this a little bit more rigorously in terms of the causal identification. This is implicitly using variation in pricing strategies over time, but it's maybe using a lot of variation in exposure to prices that we might worry is endogenous. Was there, Andre? Did you have a question?
I'll just wait.
Okay.
Maybe I'll ask a very quick question.
Yeah.
Given the result you were showing there, do you think the main effect you're finding price is on purchases or something like search, right? Especially since you find this positive effect of the variation, right? We think that if people see more variation in prices, then they're going to be more likely to search longer, and then they might end up buying different things. So do you also sort of change the dependent variable or think about the mechanism through which you get this effect?
Yeah, so I that we've looked at a measure of search directly, though at any point, Madhav or Diego may have be able to provide a better answer to some of these questions. So I don't think we've really looked at search directly, but I mean, that could be a relevant mechanism via which this could happen, right? So, like I could say, because I could say, this price is high, but maybe I could buy a different brand of toilet paper today. And I perhaps know that it's high because I've seen a lot of other prices before, right? And price is really salient to me. So I say, I don't want to buy at a high price. And I'm seeing alongside this product, a bunch of other competing products. So certainly one way the price sensitivity can be manifest is that I'm looking at a search results page for a product category, and I'm going to buy products more heavily based on being low priced at that time. Yeah.
Dean?
Go ahead.
In the specification, in the specification, don't you want to disentangle between the stock of prices for that particular product and more generally changes in prices that the consumers observe?
Mm-hmm. So I think that could be an interesting thing to do, and also to think about what's the range of prices that price changes that are psychologically relevant for the consumer. So it might be that if I'm seeing gas prices change a lot, right, at the Safeway gas station, that's not affecting my price sensitivity in the same way in the store. If I was seeing the pasta sauces prices changing, and then I'm looking at pasta sauces. So I think that's a relevant question. In this version, we haven't done it in that category specific way. In some previous analyses, we have sometimes done it on a per product basis, so the price changes just for that product. We find kind of a similar result, but one of the things is that kind of removes this element of that it could actually be spilling over across the retailer's assortment. Even to cases where I'm just visiting a product for the first time. Yeah, I don't know. Is that sort of along the lines of what you were thinking, that maybe we could think about sort of more or less psychologically related products, or even ones that are more or less likely to be substitutes?
Yes, that's pretty much, yes.
Yeah, I think that could be an interesting thing to try out. And actually with this data from the same retailer and some prior work, Madhav has done some really nice work embedding all of the products in a space where we can kind of get at how much their potential complements or substitutes for each other. And so it might be that there's a way of producing some kind of locally weighted version of this price variability stock using that kind of a setup.
I think my question is somewhat related also, so I'm just going to ask it very quickly. So the types of products that you have here, I mean, are products that are subject to stockpiling and not so much durable goods. Is that right? Or
yeah. Overall, there's not a lot of, these are not like, we're not including TV purchases, et cetera, here. This retailer did have some electronics, et cetera, but I believe in the set that I'm showing you, it's all kind of like these household product categories. Because
it is kind of consistent with something like the Coase conjecture too, but it's here probably the intertemporal incentive of consumers is more, I might want to buy early or might buy more, stockpile on or substitute between products depending on what is cheap right now. Yeah. Okay. Thank you.
Yeah. Cool.
Sorry,
okay. So
just one more thing related to that. I mean, this really seems like an intertemporal substitution issue. If I know that there's a lot of variation in prices, then I should just wait around until the price decreases. So could you look at, like time, do I kind of wait to purchase, time to purchase as the, dependent variable or something like that?
Yeah. Yeah, that's interesting. And I think that would, I mean, one of the things that, obviously would be an approach here that we're kind of not taking is to imagine having a choice model, a full choice model for each of these product categories. And part of the reason we haven't done that is the scale of the data and the number of categories here. And, often when people do this kind of choice modeling work, they focus on one little category, and we're trying to sort of do something a little bit more synoptic here. But I imagine, how that could be helpful is in getting at, okay, when do you finally purchase in this category? Because part of what I think is happening here is that people are purchasing, at least temporarily cheaper alternatives in a category. And perhaps, another relevant thing there is, thinking about how rational potentially some of this behavior is. If I'm seeing all these price changes, for this focal product, then maybe it is a good bet that if the price is high now, it'll be lower again later. But if I'm seeing a bunch of price changes for other products, depending on the relationship between those other products and the focal product, there may be really no reason for me to think about, oh, I should actually strategically delay, right? And so it could just be much more psychological around the salience of price. So perhaps that again recommends the value of trying to think about a version of this price variability stock that is different for, for kind of a focal product, focal category, and just other products on the site. Okay, so just to get to a little bit more of how we're thinking about where is some as good as random exogenous variation coming from in the prices, and also the price variability stock that we can use, so that we are doing something that's a little bit more causally credible than just this kind of fixed effects or regression that I showed earlier. So we consider two different sources of such variation. The first is that there's some of the pricing is kind of happening at maybe some more aggregated level. And so prices may change in ways that reflect some broader changes that are happening, such as supply shocks that are affecting some whole category. So I'll say a little bit more about that. And it also could be that there's variation due to the user's precise times of visits, because users might visit at a particular time just in time to see some new price. So those are the two variations that we're going to try to use. So the first of these is going to generate the idea of using a bunch of other price instruments, right? So other related prices to some focal product's price can reflect some common shocks, like common supply shocks. They could reflect some common schedule of price changes, that all the prices are changing at a particular time, but they don't directly affect focal purchases, right? So I think the classic example of this is where Ellison and Ellison use the prices for other speeds of RAM as an instrument for the prices of some focal category of RAM that people might be purchasing in electronic stores online. So that's kind of the idea here. So we're going to consider three different related price series. The first is prices for the same product in the past set of days, but not seen by this particular user. And then prices for another product in the same category, but that was not viewed by the user. So we could think of this as maybe some similar sort of product, but it's one that they didn't view. And then finally, we consider prices for the same product in another US state, because as I mentioned, the prices are potentially different in different states. And so these are not the prices that somebody is exposed to, but they may reflect some of the same underlying supply or competitive shocks that are affecting the focal prices. And so we can use each of these price changes as instruments for the prices that somebody actually is exposed to. So in order to do that, we're going to do this in an IV setup, but it's how we implement this, because we're using this quasi-Poisson model, is through a control function specification. And so we're going to be fitting this kind of model that we looked at before, where we have the units purchased, the prices, the price variability stock and their interaction, a bunch of time varying covariates and fixed effects. But we're going to instrument for these endogenous variables that are these key things of interest to get at this sensitivity, this price sensitivity, by including residuals from two regressions that predict the endogenous variables with one or more of these types of instruments. And so the first set of instruments is prices for the same product from the past different windows of days that were not seen by that user. So that's sort of getting at how much price changes there are in this time period that they aren't directly exposed to. Prices for this other product that we think of as a substitute, but it's a product that they haven't actually viewed. This ends up being somewhat limited in sample size because we need to have a suitable unviewed product for that user. And you might also worry that somehow that maybe makes this dependent on their search behavior because it's an unviewed product. Perhaps my favorite is this one, the prices for the same product in another matched US state. So if you're shopping in one state, then we can pick another matched state and consider what the price for that product was in that other state and use that as the instrument. So we're going to be using things like how many price changes, how many unique prices were there if you had visited at the exact same time, but you had been visiting from another state, and use that as the instrument. Okay, so that gives us results of this kind. So the first column is what we just looked at before. These are the results from this kind of fixed effects only baseline model. And then the second column gives similar results for using the price unique changes among the unseen products as the instrument. And so we've seen the second column kind of actually very similar estimate for the price sensitivity and generally similar magnitudes of estimates for the effect of the price variability stock, that kind of main effect of that is associated with higher rates of purchasing, but then that there's this increase in price sensitivity, so that this price elasticity is going to be more substantially negative if you have been exposed to a greater variety of price changes. And then we see kind of similar results for this version where we consider the prices in the other state. This sample size is a bit smaller because we're only considering the largest states in this particular analysis. And finally, if we use this other product's prices, this product that you haven't seen in the same category, it's a sample size a bit in a different way, but also gives kind of qualitatively similar results here around everything from price sensitivity to the effect of price variability stock on price sensitivity. So that kind of suggests that we have this relatively consistent picture from this observational analysis through to using all these kind of other price instruments. So now I want to say a little bit about another approach that kind of is a little bit more work in progress to getting at these sort of effects, but that means that we're all the more open to getting feedback on it. So that's using the idea of haphazard visit timing. So we think of the precise time that a consumer visits as good as random. And so then the price that a user sees depends on the time they visit. And so that means that if they had visited slightly earlier or later, they might have seen a different series of prices. Okay. So there's some antecedents for the idea of using this kind of idea. So in this paper by Donnelly et al., they're looking at a kind of a complex model of complementarity and demand for products in a supermarket setting. And that supermarket chain changes prices every Tuesday night. And so in some of their analyses, they really focus in on people who visit on Tuesday and Wednesday as a way of better evaluating their model in response to possibly exogenous price changes, because maybe somebody who might have visited Tuesday might as well just have visited Wednesday instead, right? And then also more generally, many studies ostensibly rely on a kind of high frequency price variation for identification of price elasticities, where the idea is that there's some rapid price changes happening that can't possibly be reflecting changes in consumer demand at that time scale. And so there's an argument that those are as good as exogenous for this purpose. So these are sort of these maybe more general or more simple versions of this idea, right? But in this setting, because there's so many price changes, it's not that price changes just happen, Tuesday night. They're happening all the time. But we do have this really detailed data about when people visit. So this can allow us to think about what would happen if people visited at slightly different times. So we could specify some distribution of possible visit times, where, consumers are going to, randomly visit at, some time in some window. We could draw many samples from this distribution. Then the expected price variability stock, and the product of these two, averaging over this distribution, we can think of them as something like design-based propensity scores, right? They're the expected exposure that somebody would have to each of these three different treatments that we have in this analysis. And in fact, that idea is kind of really spelled out in a working paper by Boris Yak and Hull. So under some additional assumptions, if we kind of are putting this in the context of a semi-parametric model, we can adjust for them just in that direction, and thereby purge all the endogenous exposure to these prices, only then using the variation that happens from some of the minutia of visit timing. We can also use this distribution to compute a null distribution for a key test statistic and do Fisherian randomization inference. Okay, so what this would look like is that here's somebody's actual timing of visits, right? This is what we looked at before, okay? Then we can think that maybe even though they visited at exactly 9:35 on January 14th, they could have visited any time in, say, a 2-hour window, 1 hour in each direction, right? And so let's imagine some other sampled counterfactual possible series of visit times for that user that are shifted by some random amount in either direction, okay? And we could consider a whole bunch of such samples. For each of these samples, we can keep track of not just what particular price they're exposed to on some focal occasion for some focal product, but we can also keep track of what is their price variability stock? How many unique prices have they been exposed to over this whole time period, right? So that's kind of the general idea from this haphazard visit timing approach. I think there's actually a bunch of difficult questions here, in part because this price variability stock is built up over multiple visits. So you have to make some choices about, okay, if we're going to imagine that somebody might have visited slightly later on their first visit, would they also perhaps have visited slightly earlier or later on their next visit? So should we be shifting all these together with each other? Also, if I'm around for my fourth visit, this might mean that I didn't buy on the previous 3 visits, or that I bought on the very first visit and now I've eaten all those almonds and I'm back for more almonds, right? So if we consider counterfactual histories of exposure, this could be difficult because I might have been in some different state in terms of how recently I've purchased, what my stock is for some product. So there's some challenges specifically with looking at the price variability stock because it stretches over time in this way. And so I think some of this analysis is more straightforward in the case of just looking at price. And we think actually that's already an interesting contribution, because really pushing on this haphazard visit timing idea, something we haven't really seen spelled out in this way. So what I'm going to show you now is just results for price sensitivity, not yet including the price variability stock effects, because there's a bunch of ways of doing this and we're trying to figure out what the right way is, and happy to get thoughts on that. So here's what this looks like for price. So here's each point here is showing us the expected log price under random visit timing. So you can think of this as on the x-axis, that's something like the propensity score that's capturing, given approximately when somebody visits, right? What are the prices that they would have been exposed to if they visit around that time? So given that I visited at this particular time at 9:38 a.m. on January 14th, if I had visited anywhere in a window around that time, what's the mean price I would get for that product? And then on the y-axis is what's the price that I actually got at that exact visit time, right? So the idea is that this vertical variation here is the variation that we want to use. Given the general time I'm visiting, the type of product I'm visiting, what state I'm in, all these kinds of things that are determining the price of the product, there's some variation based on the exact timing of my visit, Okay, and so then we just want to use just that variation. So here's how that then works in the context of a regression. This is just with the price, not with the algorithmic pricing price variability stock yet. So just, if you just do the observational regression with log price, you get one price elasticity. Then we can control for actually the expected price. And so that's what happens in the second column is this expectation. This is taken over these random samples of alternate possible visit times that somebody might have made. In this case, this, it seems like in part because we have these fixed effects for user, product, and weeks, there's not necessarily a huge change in this particular estimate of the price elasticity. But this is kind of this idea in practice here. So this is how you could use this sort of expected price exposure in the context of just a regression. You could also think about running a regression like this repeatedly using possible null price exposures. So just consider substituting in for the log price some random draw of an alternate price I might have seen. And that can be a way to do Fisherian randomization inference here. So you think this is the distribution of Z statistics under a null distribution where the price in the regression is not the price that I saw, it's some randomly drawn price that was adjacent in time to when I actually visited. And then we see out to the left, the observed Z statistic for log price, which is much larger, much more extreme than this null distribution we'd get. So this kind of approach could be used both for kind of just in the regression framework as a way of controlling for these unobservables, and also potentially to do inference as well. So I'd be interested in any comments people have about this kind of haphazard visit timing approach. And what we're in the process of doing, and actually have done in a few different ways, that really want to be confident about is applying this to estimating these kinds of algorithmic pricing induced price variability stocks.
I have a question. I don't know how well you're doing on time, but quick question on the idea of extending this to think about price variability. Are you potentially going to compare people who have similar visit histories, and in the sequence of histories, every visit might differ a little bit? So I guess the question is potentially that seems to be kind of a matching-like approach on a high-dimensional object. How are you thinking about that?
Yeah, I mean, one way you could think about this just in the price case would be to think about this as matching on expected price. So sort of a non-parametric way of controlling for this variable would be actually to match on expected price given somebody's visit timing, and either to do matching or sort of to flexibly control for this in a regression, which would be sort of a similar kind of idea. So you could do that. In the case of say the price variability stock, one of the thoughts is that what really matters about my visit timing for the purpose of the potential endogeneity of price variability stock is what's the expected price variability stock given my visits. So it could actually be that it turns out that, the 14th and 15th of January, 2019, were just really similar in terms of the price time series on those 2 days. So even though you visited on the 15th and I visited on the 14th, that doesn't really matter for our propensity to get exposed to different sorts of price variations. And so once we compute our price variability stock, maybe we end up having very similar price variability stocks because we visited the same products on different days, but those days were sort of very similar. And so even if you look right around when we visited, a lot of the price changes and the price time series in that neighborhood was very similar. And so then you could actually think about it from a matching perspective and match people who have similar expected price variability stock. But as long as you're kind of willing to lean a little bit on the structure of this log linear model, you could just include expected price variability stock in the regression in the way that I am doing here with price, where we just have this mean permuted price in there. You could more flexibly control for the expected price. But here we just sort of do this in the context of the model.
Dean, why don't you look exactly at the variance then at any point in time instead of, because the variability stock is kind of a very, I mean, it seems like what you want to capture is really like a second moment of the distribution of your belief that, or of the expected price that you might see at that point in time.
Right. So I think that's an interesting idea. So that idea would be that actually maybe I as a consumer know something about how variable it is in that time. So I guess I'd say
or
that's,
even if it's not about the consumer, but also kind of from, or I don't know, if you go back to the graph that you had with like, I mean, here you're basically just looking at expected price, but you could, if you have a second dimension of, let's say, the variance of the variance of the expected price, I guess. Is that the right thing? Yeah.
Well, so this expected price is computed over these possible alternative visits. And so, yes, definitely in some cases, it may be that first, if you imagine shrinking the window, if you say, you know what's as good as random is whether you visit within a 3-minute period.
Yeah.
Well, if you do that, actually, we're going to run out of a lot of variation, right? In a 3-minute period, there's a lot of price changes happening, but like there aren't that many price changes happening such that, you know, many people are going to get alternate prices. And so conditional on your expected price in a 3-minute window around your visit, there's probably not much variation in your observed price. And so we'd be kind of conditioning away most of the variation. Yeah, there is difference in variation here in the observed price given the expected price. For the actual, you know, this measure of the price variability stock, we really want to keep track of what are the prices that you were exposed to, compute a measure of variability on that set of prices. And then we can think about actually what's the distribution of that quantity, right? So here, like we see that, you know, on this one sample, this person ends up with a higher price variability stock because perhaps exactly when they did it, it turned out that it was still $4.99, but maybe it was, you know, slightly earlier or later, it would have been a different price, right? And so then we could compute that. Yeah,
because the price variability stock, I guess, is more from the consumer's perspective. But I was just thinking, if you think of this kind of this logic of, oh, you're experimenting, basically you're just running some counterfactuals that somebody's arriving maybe a little bit earlier or a little bit later. The probability of seeing a different price depends probably on the product or many other things that are summarized in kind of the variance of that pricing algorithm at that in that interval of time or something. I don't know.
Yeah, I mean, perhaps one way of thinking about this is that it's precisely the presence of some kind of rapid price changes that allow us to use this visit timing in this way to think of having this quasi-random variation. Because if there weren't many price changes happening, then you wouldn't have, you know, anybody who's being exposed to multiple prices is being exposed to multiple prices for good reason, because they visited, you know, a week after the price change, right? And that probably reflects some really different things about their demand for the product than if they'd visited a whole week earlier, right? But because there are all these price changes, we can kind of consider these, you know, really nearby possible worlds in which somebody visited slightly earlier or later. So
thanks. I'm not going to take more of your time. Yeah. Thanks.
Oh yeah. Well, anyway, I think actually, so there is, we do have a lab experiment as well. Actually, well, a couple lab experiments in which we do this kind of thing with MBA students or Mechanical Turk workers and give them different sequences of prices and a task where they're buying a product given some budget. And we do see that there's also increased price sensitivity in that context, but I don't think I have time to go into the lab experiments. So I'll just summarize and then take any more questions. So really, I think often when people think about algorithmic pricing, they think of it as being about showing the right price to different consumers, or sort of different prices for different versions of the product. Like if I'm taking an Uber from here or from there or late at night, it's kind of a different product. But part of what can happen with algorithmic pricing is that the same consumer is seeing for the same product different prices over time. What does this do to consumer behavior? And we've presented some evidence that it increases price sensitivity, and we're in the process of doing some more analysis in this setting. We think one potential mechanism driving these results, and there's a bit of evidence of this from the lab experiments as well, is price salience. So it just makes the prices more present to mind when people are making decisions. And this could have some implications for firms who are considering adopting algorithmic pricing. Anyway, thanks again for having me in the seminar, and happy to just keep discussing these topics and get any suggestions people have about this work.
Thank you. So just so because you're talking about these experiments, I think early on when you're talking about potential mechanisms of salience, fairness, and antagonism, Yura has a question on the sort of the fairness paradigm, how whether potentially there's room to think about different, so there's room to zoom in on different mechanisms of potentially whether consumers are thinking sellers are greedy or consumers are thinking it's unfair that other people are paying less than I do, and so on. So I don't know whether you want to talk about any of the experiments that potentially can speak to any of these mechanisms.
Yeah, I don't know that the experiment can really address this fairness question, but I think that's a great thing to think about. And I think some of that maybe gets at the importance of the choice of how we define this price variability stock. What does it mean to be exposed to multiple prices? And in that process, one thing I didn't mention is that we consider price changes that I think are less than 10 cents and that don't change the left digit as being negligible and not important. So those are prices we're not counting. But you could think about other ways of capturing both the number of unique prices and really how much variability there is. Because I think she asked maybe if there's a lot of variation in the actual scale of the price changes, perhaps I'm more worried about fairness, whereas perhaps smaller price changes that don't seem like too important do just make price more salient for me, even if I don't think of it as being really unfair that I'm paying $4.50 instead of $4.25 or something like that.
Perfect. Well, first I wanted to say, like, one of the significance of your results, which I think is worth highlighting, is it is a pretty big critique to those of us who do price algorithms for learning. Because the key idea is we're trying to learn things like demand elasticities. And what you're saying is that the actual process of learning is actually changing the object you're learning. So I think in that sense, it's sort of a nice critique to a large literature, nice growing literature, which I think you guys should acknowledge as well. One of the questions I have, and again, going back to some of the discussion you had with Aniko, is, and this is why I asked the question about data generating process for these visits. And particularly things that might cause concern is things like search. So if I'm visiting 4 times because I'm trying to find a lower price, now you're comparing someone who's visiting 4 times to someone who's visiting or 4 times for buying 4 different products. And now the algorithmic pricing number is capturing something other than just pure algorithmic pricing. It's capturing something else that's an underlying data generating process that's causing you to see different prices. I'm not
right.
certain.
So just on that, I think that is super important, right? And so, say in this where we're computing, the expected price or expected price variability stock, that's given all of your visit timing up till the present visit. And so that would condition on that. Now it could be that, that people with different numbers of visits can end up with similar versions of that stock. So often it makes sense to actually still include the total number of visits up till now, even as an additional covariate there, like we do in this regression, and these same covariates, not the expected expected value under this permutation distribution, but the other ones like the number of visits and the number of products viewed do appear in the other regressions as well. So
yeah, so I guess my question was, when you extend this to include the algorithmic pricing. Now, if you take different permutations of the prices you observe, that could vary the number of visits I made, right? And then I think things get a little bit more tricky, and I presume this is the reason why you haven't implemented it yet. But
right,
I think
or why we've implemented it, but I'm being cagey, like giving you one version of the results, et cetera, right? Because
Exactly.
yes, I think that's definitely true, right? Like here in this diagram, if this user, their first visit, they actually saw $4.99, but if they'd visited slightly earlier or later, they would have seen $3.49, right? And what we might imagine is that actually they didn't buy on this first visit, and they would have bought on these counterfactual visits, right? And so I think that's important to keep track of there. Now, it might be that, okay, that's fine, because actually what we're going to do is not think about their exposure to price variation from visits to the same product. So you think of this is the visits where they saw product A, but now we're looking at purchases for product B. So this could still be potentially good variation in their price variability stock exposure, because this isn't necessarily changing what their stockpile is of product B at the moment. But I totally agree. I think that's one of the challenges. Certainly, one of the things you can do is just consider whether the present visit was earlier or later, and that present visit may not just be a single product. Usually, it's not, because somebody like views a whole search results page or something like that, right? So they're seeing a bunch of product prices there, and we can just think about whether that last visit was slightly earlier or later. And that gets around some of the issues that you brought up. One of the challenges is that it maybe doesn't give you as much variation in some of these, this pricing stock, because it's only looking at, moving around the present visit. So if I, had some actual observed value of algorithmic pricing stock under that kind of imagined experiment, I could only have, somewhat different versions of the algorithmic pricing stock, because, everything is the same up to visit 3, and then, it's only during visit 4 that something is different. I don't know if that helps address some of your.
No, that's fair. I think.
So it's 2 minutes past 1. So I want to thank everybody who's participating again. So let's end our official part of the seminar, and everybody's welcome to hang around and keep discussing. And
Great.
If you're in the audience, if you're interested in joining the conversation, just raise your hand and we'll promote you to the panelist.
Cool.
So Dean, a conceptual question. How do you think if this is related or similar to the stream of work that talks about if you run frequent promotions, then consumers become more price sensitive? Is it just because this is on a much larger scale and things are changing that much more frequently now given the technology?
Mm-hmm. Yeah, I think it is really related. I have to a little bit punt on that and say I don't know that literature super well, but I think Madhav and Diego know it a bit more, and some of it, I don't know. I should talk with my colleague Duncan Sinister more about these things, but my sense is that it is quite related to that. I think one of the differences, maybe psychologically, is just that these are not really labeled as promotional prices, and so perhaps I'm used to the idea that that's actually intending to draw my attention to price. This is this thing that the price is just changing without saying this is a really good price right now. And so I think that's a feature of it that's very different. And just the frequency of exposure to these price changes is really different. And we're seeing it in categories that are really different than some of those categories where I think a lot of that literature has been focused, right? Where you have like brands in fashion, et cetera, that want to have a credible kind of commitment that you're getting a good price and we only have our 2 times a year sale. These are just kind of ubiquitous household goods where a lot of this is happening now. But I think that's a good question. I don't know, Madhav or Diego, do you have any thoughts on that?
I think broadly, I agree with what you're saying, Professor Eckles. I think the context is quite different. But also one thing that's sort of unique in this case is many of these being consumables, they're repeat purchase goods. So we do see some of these effects not just being driven by promotions, but by the idea that these products are just purchased way more frequently at scale. And I think that's a key distinction from the other literature.
Mm-hmm. Yeah, and maybe that's also related to some of the intertemporal aspects of this in interesting ways that perhaps we should explore more, right? That It's not just a matter of timing when I'm going to buy this expensive leather purse. It's like I need my almonds, you know, but I can also stockpile them a little bit, etc. Yeah.
Hi, Dean. If I could jump in. So I asked a question earlier in the chat about treating search as exposures as well as clicking on a product page. And I just wanted to sort of come back around to that, because the concern I have is that the longer a customer or consumer searches, just automatically, the higher is going to be the price sensitivity. I mean, it's going to be weekly increasing in the extent of search. And so I'm concerned about this confound that increased price sensitivity is going to be causing increased search, which causes increased price variance, and this causes this regression result that you're getting. And it wasn't quite clear to me that the regression, that the IV strategies you use really control for that, because I think all of them still operate through this length of or number of exposures. So this variable is still going to be weekly increasing in the extent of search, even in the IV specifications. And so it's just, yeah, concerning to me that by casting such a wide net on exposures to different prices, you're sort of increasing the impact of this confound if it is operating.
Yeah. Yeah, I think that's an important question. And I guess maybe how I would think about it is less that the search results thing is a problem. I mean, one subtle point is that we actually only consider price exposures in the first 2 pages of search results. If somebody searches clicking random pages, that's a very small amount of the data, but we don't consider that. But I would say, even if we weren't considering the search results page, if we were just considering viewing products, I'd be worried about the idea that, yeah, you just have described consumers or consumer product category pairs that are ones where that consumer is really trying to get a good deal or buy the best version of the product for the price. And so I think that's a concern. Now, we do include these time varying control variables that are their number of visits and the number of products that they view. And so that captures some of that, but I could imagine that maybe one just very actionable thing for us to do is consider other various like enriched versions of those control variables that would maybe give some sense of how much of an issue that is, and are some of the results stable to different ways of, you know, doing basis expansion there, kind of featurizing those things in different ways. And then pretty explicitly, that's also one of the goals of this like haphazard visit timing stuff, is to think about, okay, for somebody who visits just like you up till now, but kind of, you know, slightly different in their timing, what is their exposure? Because yeah, I think that's definitely an important thing to watch out for. And maybe there's actually a nice way that we could do an analysis that kind of gets at that as a cautionary tale that would perhaps generate effects that are even much larger than what we're seeing.
Yeah. Okay. So yeah. So maybe I still haven't wrapped my head around this timing difference thing that you're doing. But certainly sort of like the idea of matching that Yufeng was talking about does sound like it controls that to quite a great extent.
Yeah, and I mean, obviously, I didn't actually show you full results with that, so it's okay not to be convinced by the results that you haven't seen. But you know, in the IV setup, we do also have as controls their prior purchases, the number of their products viewed, and their number of total visits up till this point. But I think point taken that I could imagine maybe it's good for us to control exactly how many search results pages they've seen, whether they go to the second page of search results ever, these sorts of other things that would capture some more richly how searchy is this person, and maybe how searchy is this person in this product category even.
You know. Yeah. Cool. Thank you.
One more. I don't know if I missed this, but do you see whether price variation also affects the order in which people are shown products on the, like in my, you know, the sellers experiment with prices for that goal in order to show their products, you know, and then the salient story sort of could account for this. It would come from this mechanism, I guess.
Yeah, that's interesting. So here, this is not a marketplace retailer, so at least these prices are not being, this high frequency variation is not due to individual sellers. Yeah, but I think that would be good to look at the position of the products, though. Yeah,
because at least then you could, cancel like at least one of these mechanisms that could affect saliency. I know you're thinking about saliency in the sense of maybe price sensitivity, but I'm also worried about, like that some products are just now more visible because their prices are lower and therefore they're shown higher at the top and something like that. Anyway.
Yeah. I think that's interesting, and I'd have to think
I
about
guess in practice, companies play with prices for that reason.
Right.
Either sellers themselves or the platform. Yeah.
Right. And in some cases, even if this isn't affecting default rankings of things, consumers can choose to rank things in that way. Now, I do as a consumer check, sort price from low to high, that in some ways is me externalizing my price sensitivity to the algorithm. So that's not necessarily saying that like somehow like I'm not more price sensitive. It's just I'm getting help in my price sensitivity in that way. And I could always sort by price before, but now that's actually guiding my choices maybe more than it was before. So yeah, that's actually, I mean, I wonder if we are able to tell when people have actually what their sort rules are, because I feel like that would be a cool. Oh, Madhav is shaking his head no. He knows all the deep details of this data.
Part of that, thanks for the point, but one of the things that we do know the exact position of the product on the page. So in some way we can control for that, but we don't know whether a sort rule was applied.
Yeah, that's fine. I guess, I mean, sorting is interesting, but a separate topic as well. So at least the first part. I know from other data sets, sorting is maybe like 30% or so of the data. So it might be bigger in your case. I don't know, but probably not a huge part of the behavior. But
and I don't necessarily see the sorting as bad. But yeah, that does seem useful for us to think about what, how is this affecting the default ranking as well, which is kind of an interesting thing as well, especially.
Yeah, no, all I was going to say is that even a small price change that you're thinking, you might want to ignore, but it could affect the position a lot.
Yeah, I think that's a good point. And I think it's also could be an interesting point where maybe the different parts of the firm may not really be communicating always super well with each other, right? Because you could imagine somebody's doing algorithmic pricing in a way that's setting the prices in a great way, but not necessarily accounting for the fact that a whole bunch of the effects are just via the ranking. All they're doing is like tweaking the ranking a little bit, and they could maybe get a bunch of those effects by tweaking rankings without changing prices. So I think that's it's a really interesting thing, also from just understanding what how
optimal. Is this yeah. Anyway, very cool work. Thanks.
Hi, Dean. So my question is related to, did you see any difference according to like the consumer behavior? Like, for example, did you check if they've like actually bought the same product with different prices? So some consumers might be, say, more informed and some might be more naive. And then that's something that you might pick up as price sensitivity. Is just some consumers might be more informed about that the prices vary on this platform or something like that.
Yeah, just trying to unpack what you're saying. So I mean, one aspect of that could be if I have purchased the product before, then maybe I have a better view of what its quality is, and then I should just be less price sensitive overall, and maybe or maybe I'm fixated on that product, and so my price sensitivity is concentrated in deciding whether to buy that product now rather than another product, or
not exactly like the product per se. What I'm saying is that if I, as a consumer, for example, on Amazon, if I have seen the price vary once and I've bought something at different prices, so like the same product I have purchased at different prices, then I am someone who is informed about sort of this price variation, then I would be more likely to be someone who would search more and be more sensitive to the price variation rather than the price. So I might behave differently than someone who's, not informed about it. So
yeah, I mean, that'd be an example where it seems really salient, right? Like, it's not just that at some point I may have seen different prices and I may remember them all or not, but that I actually bought the product at 2 different prices, and perhaps this could be a lot more salient. Yeah, I think that's an interesting thing. Of course, also the challenge is that maybe that suggests that you're not so price sensitive because you managed to buy the product at multiple different prices. Either that or just your willingness to pay is somewhere,
Yeah, I was just interested in like how the elasticities might be different according to different consumer type, something like that. Yeah.
Hey, Dean.
Yeah, I think that's
an
interesting question. Yeah. Oh, sorry.
Oh, sorry. I just have a quick comment. So this is super interesting. So I'm particularly interested in the approach, so like a matching-like approach that you were talking about towards the end, potentially applying that to measuring the causal effect of price variation beyond just effective price. As you pointed, so I asked you about how do you think of matching under high dimensional, past histories. I think propensity score is a good answer, but of course, if you're using the number of prices you see in the recent past as the covariate and doing a propensity score matching on that thing, you're putting more pressure on the models correctly specified, right? Like the consumers actually care about the number of prices, not anything else. So that's a stronger assumption than just the first regressions you're running. That's not really putting that much emphasis on that functional form has to be correct. So I was kind of thinking related to a bunch of the questions asked during the talk on, what's a data generating process? How do you think about search and so on? Is there a way to formulate kind of a theoretical prior on what the right functional form actually should be, like why consumers should care about, for example, the number or potentially the variance of price? If we have a theoretical prior, I think it's easier to process, hey, this is the right model, and then that kind of naturally connects to how you're then doing the matching and so on. That seems to be a viable flow.
Yeah, so I think I'm definitely concerned about some of the sensitivity to the model specification, and like that can come in multiple points. I mean, one is like, what's our model for these visits, right? So I kind of skimmed over that a little bit, but basically, one simple model is people are visit at random in some small interval, right, around their visits. Now that somehow is not the right model. That's not really quite right. Maybe it doesn't matter exactly if that's quite right. You could consider different sorts of ways that people might be randomly visiting. And one of the interesting results from this Borisiak and Hull paper is that there's a kind of multiple robustness property. So if any of those is actually the way that people are visiting, then if you include multiple of them as controls in the regression, then you get what you want, which is that you get only this exogenous variation that you're identifying the regression off of. So that's sort of the model sensitivity around the model for the visits themselves and how that translates into this stock variable. Then there's like the second part, which is, wait, is that the right stock variable? And I think that's a really good question. And maybe there's, some of that could just be a matter of robustness of trying different versions of that stock variable. I'm not sure. I wonder what,
I guess on the first
or maybe
point,
it's what you're suggesting is having a better, more sort of cognitive science informed model of what exposure would matter.
So on the first point, if that robust, if you can potentially condition on multiple measures, I think that you're fine. I was just worried that if that, that would basically increase the dimension of variables that you have to match on, right? So, there's a trade-off there. But if that's feasible, I think you're fine, just doing this. My original suggestion was if that's not feasible and one has to sort of take a stance on the functional form, I guess I was thinking, so the hypothesis you raised at the beginning, how do we think of salience, antagonism, and fairness? I think these are very interesting sort of alternative mechanisms. I was wondering if there's a way to clarify how some of these mechanisms translate into the regression that you're running. I think that would motivate the
yeah, that would be nice if something like that worked out, right? If there was, and I do sort of like this idea that maybe, salient should operate even when the price changes are not huge, whereas maybe other concerns start entering when the price changes are huge. But I could see that also being wrong, that, okay, large price changes draw your attention, and then that makes you think more about price. So it's, but I think that's a great suggestion, like to think about what those different ways of specifying that variable could be.
Yeah, very cool paper. Look forward to reading it whenever you have a draft. I'd be super interested.
Cool. Yeah. Any minute now, but yeah.
Great. Thank you so much.
Yeah, thanks a lot. Yeah, it was really a treat to get to be the speaker in this seminar. So yeah. Thanks a lot, everyone.
Awesome. Thank you.
Thank you.
Bye.
I guess.